Hi, welcome to our CMPP 756 final project. We are a team of four. I'm Joanne, and the other three members are Kipney, Zeyu, and Wanyi. Our project is to apply and observe multiple principles of cloud computing implemented with AWS platform, containerized application, the microservice distributed system architecture pattern, and Scrum methodology. We built a playlist microservice on top of the music and user services that already provided by the course materials. We conduct the load and test with scaling tools and observe the system statistics with Grafana, Prometheus, Kiali. So to begin with, we want to introduce our team's repository in GitHub. This repository contains all the files and folders needed for the configuration and deployment of this project. So there are a bunch of basic folders where CI contains files for continuous integration, files used by GitHub Actions to accomplish CI, the files defining different versions of the test, as well as other files useful for local running CI tests. So cluster is for configuration such as GitHub and AWS. This should be treated with extra care, such as not remove any lines from git ignore because you might risk with exposing secret keys. DB is for the database service. The current version uses Amazon DynamoDB. Gatling is for simulation in order to generate different workload tasks for our application. So loader is to load data into the AWS DynamoDB table, and logs is to include those generated logs, and CLI is the CI for the music microservice. Following is the three services by its name. S1 for the first service, user. S2 is for the second music service, and S2 is for the playlist service. The tools contain scripts to start Docker and the AWS service. So outside there are the make files for instructions and specify how source files are compiled and linked. We'd use it as templates to instantiate configurations. The Gatling files are for adding load to the system progressively for us to observe and analyze the results. You can find the details, steps, and commands to deploy in the README file here. Also, each of us has our own branch for commit and merge requests and resolve conflicts. Moreover, in order to keep the transparency of the project progress, a project in GitHub using basic Kanban board style with status included, to do, in progress, and done is created. Issues are created and assigned to each team member during every sprint planning. There are basically 4 sprints for this project. In the first sprint, it consists of the initial steps such as set up environment, document the progress, and create the playlist tables. The second is the development of the playlist application with functions such as create, read, edit, delete playlist. We also started the setup of Grafana and Gatling. In sprint 3, we keep setting up with Prometheus and service mesh. In the last sprint, it's mainly about testing and scaling the microservices performance with Grafana, Gatling, Kiali, and the documentation work such as video recording and final report. We'd also like to show the Kanban board for update. So all of the issues have moved to done, and the project is just finished its organization and documentation. We can see that overall the work is roughly evenly distributed by each member. So to illustrate our newly added playlist service, I'm gonna test it locally with all functions. From the script, there are 5 functions. Create list, create playlist with name and the list of songs, and the unique ID will be returned. Write song and delete song is to write or delete a song in one of the playlists. The playlist ID and song ID need to be provided. The read and delete is to read and delete a whole playlist given a playlist ID. So to test it, first we'll go to the file's location. And with Docker opening, we'll run the container. So we then instantiate the template files. And go to the CI folder where service located. And finally, we'll run the test. So now we can see the 1 test for music and 2 tests for playlist have passed. So this is everything for GitHub repo issues and collaborations. Next, we'll start the real deployment with EKI's cluster for scaling and testing.
Let's move on to the service demo and analysis. First of all, we will set up the instance and deploy the services to AWS and Kubernetes, and then we will run load tests with no disturbance, and then we will run the load test with disturbance. So now here is our load testing plan. We will first run 1 user per services, and then we will set the replica as 1, workload as 2, and then the dynamic DB capacity will be 5. And then we will slowly scaling the number of user and at the same time adjust the replica workload and also the dynamic DB capacity to see if this adjustment can help to resolve the error. Expected total number of users will be around 1,500 among this load testing. First of all, let's start setting up the AWS instance first. After the instances is created, we can go to the website to check they are up, and then we can also check the database that has been created for the 3 tables for the services, and then we can continue to deploy our services to Kubernetes and AWS. And then we will try to check if all the services are up, and then we will continue the deployment through the provision command. So after the services are ready, we will try to simulate 1 user per services using the Gitlin shell files. And then we will try to get the URL for dashboards for Grafana, Kiali, and also Prometheus. So now we can see that the simulation that we have just entered has been running, and we can go to Kiali to see the traffics of the services. And we can see the animation showing that the requests keep running, and then we will stay and see if the service can continue running normally for 5 minutes.
Now the microservices has run 5 minutes. All traffic flow has been clear and green with no error shown. Now we add 100 users to S1, S2, and S3 respectively. That is 300 users in total, with replicas equals 1, workers nodes equals 2, DB capacity equals 5 to check performance of the service. We can see successful requests per second increases with no error shown. Average request time increases indicates latency increase. System utilizations also rises. Traffic flows run smoothly with no error. After a while, we can see the error increase. We can also check that in the Kiali graph. In order to remediate this situation, we update work node to 5. Also update DB capacity to 10. After editing the parameters, we can see successful requests increase and the error rate drops. After this, we add 200 users to each service to test the performance. And we can see the error rate decrease and keep stable at a low level. And we want to improve this. Therefore, we update DB capacity to 20 to see the performance. Now the error drops to nearly 0. We can check in Kiali graph, or the traffic line went green again. Now we repeat the simulation step and add 900 users to our service. Now the successful request number increased dramatically and the error keeps stable at nearly 0. Also, the latency becomes lower. In Kiali, our traffic flow went smoothly with no error. Now we add 1,200 users to these services, and we see the error rate keeps stable at nearly 0 except for some small error, but the successful request is still under 1,000, and we want to improve this.
Now we can add up to 1,500 users, and we can set up 10 work nodes with 10 replicas. Here we can change the maximum capacity to 200 in DynamoDB. And then we will wait until the successful request per second surpass 1,000. Okay, here we can see there's a jump in the successful request per second. It has already reached 1,000 per second. And now we can see that the error per second is 0 and over 80% request is under 100 millisecond. And the 90th percentile response time is very small. Here back in the Kiali, we can see that everything is green. It means that everything goes well, all services run smoothly, and the successful rate is 100% with 0 error rate. Now let's check the Prometheus. From here, we can see the database service are all good because the status codes are all 200. And we can add up 5 minutes at the last, so we can see the details in the 5 minutes. And we can check the status. Here we can check the S1 services in Prometheus within the 5 minutes. And we can see most of the code status is 200, but some are 500. As well as service 2. And service 3. And this is the end of our loading test. Thank you.